Hello. Today we are going to try to tackle this question. The question says, show by evaluating the derivative at t equals to 0 of exponential raised to the power of kt, in which kt is equal to log file x t, and we are asked to show that the expected value of x here is equal to k1, which is the first cumulant. Then expected value of x squared is equal to k2 plus k1 squared. Expected value of x cube is equal to k3 plus 3k1 k2 plus k1 squared. Then finally, expectation of x raised to the power of 4 is equal to k4 plus 4k3 k1 plus 6k2 k1 squared plus 3k2 squared plus k1 raised to the power of 4. All right, so quickly we are going to start this. From the question, we are going to obtain this by derivatives. So let's quickly do for the first one. For expected value of x equal to k1. So to show, from what was given, kt is log file x of t. If we take the exponential of both sides, we will be having exponential raised to the power of kt is equal to exponential raised to the power of log file x t. Now the exponential we cancel out the log, and finally we'll be having the exponential kt is equal to file xt. All right, so let me bring this up and try to apply our differentiation. Okay, so if I differentiate this, I'm going to have file prime x of t. Now, if I differentiate this using our chain rule, I'll be having k prime t exponential k t. Now we can have this from chain rule. We'll say, okay, let u equal to kt. All right, so now we're having exponential raised to the power of u. If I differentiate this, I will have exponential raised to the power of u. If I differentiate this, I'll be having k prime t. So when you multiply both together, we'll be having k prime t exponential raised to the power of u. But then u is kt, so finally we'll be having this. All right, so now from what was asked, we say a derivative at t equals to 0. So therefore, at t equals to 0, we'll be having phi prime of x equals to 0 is equal to k prime of this, and raised to the power of 0. 0 times k is 0. Exponential raised to the power of 0 is equal to 1. So 1 times this, we have this. K of this. Okay, so at this expectation, we have this is equal to expectation of x, and this is equal to expectation of x, and this is equal to the cumulant, the first cumulant. So this goes to show that expectation of x is equal to k1. So that is the first one. Then for the second one, for us to get the expectation of x raised to the power of 2 to equal to k2 plus k1, we are going to take the second derivative of what we have differentiated earlier, which is this. So we are going to take the second derivative here, and it becomes taking the second derivative, which is, if we differentiate this the second time, we're going to have phi prime prime of x t is equal to, now differentiating this using our product rule. Product rule is u v prime plus v u prime. Alright, so we'll keep this, differentiate this, keep this, and differentiate this. Alright, so in doing that, if we take this as our u, we'll be having k prime t, and we differentiate this, we'll be having k prime t exponential kt plus, if we keep this and we differentiate this, we're having k prime prime t times it with v, we're having this. Alright, so this is what we're having. Now we'll multiply these two inside, k prime t times k prime t, we're having k prime t all squared exponential kt plus k prime prime t exponential kt. Okay, so this is equal to 5 prime prime x t. Okay, so when we set this at t equals to 0, this becomes 1, this becomes 1. This is the second derivative. The second derivative is the k2 for the cumulant. Okay, and this is k1 all squared, and this is our expected value of x squared. So it becomes expected value of x squared is equal to k1 squared plus k2. So that is our second proof. Expectation of x to the power of 2 is equal to, since this is commutative, we can still write it as this. Alright, so that is the proof there. Okay, so in the next video we're going to do for that of expectation of x raised to the power of 3 and expectation of x raised to the power of 4.